Hello everyone, welcome back. So we continue our discussion about exploratory data analysis in CEIS110. And in this video, we will begin to focus our attention to data visualization. And to do that, I'm going to use a set of standard data sets, and I'm going to provide you with some links so you can see the source of your data. And these are popular data sets that are used in academia to learn data analytics. So that's why I want to use a reference that is common across the community. We can also use other data sets from Kaggle and data sets from your own use cases, but then you do as you learn. So this is a learning exercise, it's a learning experience. So I'm going to use a standard data set. And I'm going to use a framework that originated from the R computer language by Leland Wilkinson. And that's called the Grammar of Graphics. So there is a book that is published. And the reason we want to use that framework, even though it came from R and we're doing Python, it's important to think to be organized in our thoughts, right? It's important to have a framework that we can follow. So let me describe what that is first and foremost. The grammar of graphics comes from Leland Wilkinson, and it focuses on the data and what you're going to plot. It focuses on different aspects of the charts that you're going to generate. First, the first aspect or the first point that, oops, let me run this again. Let me get a pencil so that I can highlight. The first point that we want to highlight is data. So the first one is data. Then the data is the data, right? Is the source that you are trying to plot. Then the other concept is called aesthetics. And that is the color, the size, what it's going to look like, the shape, opacity. It's important because when we visualize, we as human beings are going to look at this visual and we're going to have an impression of what that data is telling us. So the aesthetics are important for us to quantify, to have arguments in our plotting methods, so that when you create those visuals, they come out the way you want them, in the way that they're going to be easy to see, the color that you use, etc. So aesthetics. The next one, the concept is geometry. And that what he refers to, Leland Wilkinson, here it refers to the type of chart that you'll use. Are you going to use a line plot or box plots or bar plot, etc.? That's the geometry. The other aspect is called facets. And that has to do with having multiple charts next to each other as facets, because you may want to compare data from one type of data set, one slice or one filter data set against another one, so that you start to begin a story behind the data. The next one is coordinates. That defines how you're going to position your data. That's going to become more obvious. And so that's coordinates. And the last is themes. You want to have certain theme to have uniformity when you create your visuals, all right? So that's the framework that we want to follow, and so I'm proposing that here. And so let's do that. Before we use the data sets, when you do this in your computer, you must make sure you've installed New York City Flights 13. So you run on your console a pip install. And you can search on Google how to do that. If you use Anaconda, you use conda install like this. I have a link here that I've shared with you at the beginning that talks about that. so that you can use this data set. That's just a requirement, all right, before we do anything. And then we're going to use these libraries, all right. So the first library that we're going to use, and again, part of what we're learning is we're learning about methods and libraries and modules. So the library that we've been using already is pandas, right? We've been using pandas for some time already, relatively speaking. So we have pandas, and what did I say about pandas? To me, pandas is the most important library or module in data analytics, at least for data wrangling, data analytics, as many others as you move forward in your studies. The next one is Matplotlib. Matplotlib is the second one that I discuss here, and that is your basic plotting library in Python. And the next one, there is another library called Seaborn, and Seaborn is more specialized. Well, I don't want to say it's more specialized. That's not the right word to put it. It's just a different framework, a different way of doing this grammar of graphics that I described above, that is going to simplify the way you plot. And you will find out that Seaborn and Matplotlib actually work together, that Seaborn is going to utilize some of the methods from Matplotlib. Then we have other libraries that I will start using, like SciPy for science, and that is for statistics, how we're going to be using it. And another one that we haven't used that I will be describing is NumPy, which is for manipulating or working with numbers. So we're going to be using that. And again, don't feel overwhelmed as I present all these libraries. This is something that we will be learning as we go along, but I just want to propose that we import them right away. And then in the next import that we have here is importing from New York City Flights 13, which is a database of flights from 2013. I'm going to import flights from there, and flights is the data set that we will be using in this visualization, at least at the beginning when we cover histograms. Then later on we may find other similar data sets. I did something here that you will be wondering, why did we do this here? I was getting some warnings when I was testing my code that are not errors, they're not impacting the code, but they're warning me because they're changing some things in the future, and they're letting me know when that happens we can look at the code. For now, I'm going to ignore the warnings. So that's what I'm going to do. So then what I'm going to do next, since I did the import of flights, that in itself took in flights right there, flights. Let me write it for you, make it very clear. Flights data frame. I got a data frame, you can see it's a data frame already by doing the import of NYC Flights 13. So I got a data frame that I can work with. And that's what I was trying to say. So I don't have to import a CSV file or create my own data. Let's use a standard data frame. We're going to get information on that data frame, and let's see what we have. Okay, let's see what we have. So let's run the next line. And in my data frame, flights, that's the name of the data frame. What is a data frame again? It's like a table. See, let me do this in parallel right away. Let's do flights, like the first 5 records of the flights data frame. So there it is, right? You can see it right here. So, but before I show you that, these are the columns. You have year, month, day, departure time, scheduled departure time, versus the actual departure time, departure delay, arrival time, schedule arrival time, arrival delay. So all kinds of data associated with flights that were coming out or to New York City or the airports around New York City, which are what? In Newark, you have an airport, right? You have LaGuardia and you have JFK. Those are the three major airports. Okay. Then you have the flight number, the tail number. Tail number is in the airplane, the tail of the airplane. There is a number. The origin and the destination. The origin can be Newark Airport, and destination can be Chicago O'Hare, or vice versa. So those are the origin and destination, as long as they have to do with New York City one way or another. Air time, distance, hour, minute, and time hour. So a lot of data about the flight that we just took. And when you look at the head, right? The head of that is gives you a sense like tail number. There's a tail number, flight number, just numbers 1545. Origin EWR, that's the one in Newark in New Jersey, which is very close to Manhattan. And destination IAH, that's Houston, right? That's Houston. This one came from JFK to Miami, and so on and so forth. We can look up the destination codes. They are 3-letter codes. So let's describe this data. By describing the data, it's just going to look at the numerical numbers and get statistics, the count, how many, mean, what is the average of that column, the standard deviation, the min and the max, and the percentiles, in this case quartiles, the first quartile, second, and third quartile. Say 75% percentile or quartile means that 75% of this number, say destination distance, is that number or below. That's what it means. And we can look it up, what it means in terms of statistics. But right away, by doing a describe, we begin to explore what's behind our data, right? So that's what we're getting at. Then I have another command, and I'm going to stop the video after this, that I had to run because the data had some infinites, and I'm replacing with NaNs, and NaN means not a number, and that's how the infinites are going to be handled, not a number. But that is something to do with the warnings that I was describing, not much to do with what we're trying to do in terms of learning to visualize. But I just want to leave that in there just to show you that I did something a little bit extra. Just keep it in the back of your pocket. The most important thing that we've covered so far is being able to get a data set. So we got a data frame that is a pandas data frame. It has so many entries and so many columns. And the next thing we're going to do, we're going to start exploring further into this data by doing some histograms. All right, so I'm going to come back in the next video and we're going to talk about the first histograms. All right, I'll talk to you later. Take care.